Welcome to ThinkEE. In this lesson, we will explore two fundamental types of circuit connections, series and parallel. Understanding these is key to analyzing and designing any electrical system. What is a series circuit? In a series circuit, all components are connected end to end in a single path for current flow. This means the same current flows through every component, no branching. However, the voltage across each component can differ depending on its resistance. Characteristics of series circuit. In series circuits, the current is the same through all elements. The total resistance is the sum of individual resistances. If one component fails, the entire circuit breaks. For example, in all Christmas lights, one burnt bulb turns off the whole string. What is a parallel circuit? In a parallel circuit, components are connected across the same two points. This provides multiple paths for current to flow. Here, the voltage across each branch is the same, but the current divides between branches based on resistance. Characteristics of parallel circuits. In parallel circuits, the voltage is equal across all branches. The total current is the sum of branch currents. The total resistance is always less than the smallest branch resistance. And importantly, if one branch fails, the others keep working. That's why home wiring uses parallel connections. Here's a quick comparison. Series circuits have the same current while parallel circuits have the same voltage. In series, resistance add up. In parallel, conductances add up. Each type has its own advantage depending on the application. As a real-world example, series circuits are used in devices where the same current flow, like voltage dividers or some battery packs. Parallel circuits are found in household wiring and electronic systems where reliability and constant voltage are essential. To summarize, series circuits share current, parallel circuits share voltage. Both are foundational to circuit analysis and design. In our next ThinkEE lesson, we will explore how to calculate equivalent resistance for combined series and parallel networks. Thanks for watching, and don't forget to like, share and subscribe to ThinkEE for more electrical engineering lessons.